He called this a periodic table, and this kind of periodic table was acceptable to the scientists. But then of course, there were some limitations. The limitations were that the place for hydrogen was not fixed. It was fixed in his table, but actually hydrogen can act both as electropositive as well as electronegative. So, position of hydrogen was a controversial point. Then there are some elements which exist in two forms, and these two forms have same chemical properties, but their atomic mass is different. For example, carbon has 12 also atomic mass and 14 also. Such elements are called isotopes. As he was arranging according to the atomic mass, he did not know what to do with this situation. So, isotopes proposed another challenge. Thirdly, in his arrangement, at least in two pairs, he put heavier element before the lighter one. Although generally the elements were arranged in an ascending order of their atomic mass, but at least in the case of two pairs, the rule had been broken. Like this, vanadium V has atomic mass of 50.9 and that of chromium is 50.2, but V comes before Cr. Similarly, cobalt, which is 58.93, comes before nickel, which has atomic mass of 58.7. The modern periodic table proposed by Henry Moseley has taken care of some of these anomalies. First of all, he changed the very criteria of periodic table. He said that the properties of an element are the periodic function of their atomic number and not the atomic mass. So, we will write this definition: properties of an element are the periodic function of atomic number. So, obviously, if it is atomic number, isotope problem is solved, because whether atomic mass of carbon is 12 or 14, its atomic number is only 6. And then also it is the atomic number which means the number of valence electrons and finally the valency. So, the entire thing changes, even the arrangement of cobalt and nickel and vanadium and chromium got rectified because the basis was atomic number. Now, the main salient features of the modern periodic table are as follows. First point is that the number of valence electrons in the outermost shell is same for all elements of a group. Let us take the case of first group, whether it is lithium, sodium, potassium and so on. In every case, the valence electron is 1 in the outermost shell. In the second, calcium, magnesium, strontium, barium, etc., again 2. Aluminium, boron 3, carbon, silicon 4, nitrogen, phosphorus 5, oxygen, sulfur 6, halogens, fluorine, chlorine, bromine, iodine 7. And in the case of noble gases, it is either 2 or 8. So, you see, this is the one most important feature, that all elements belonging to one group have same number of electron valence in its outermost shell. Now, this also means that this does not mean that the number of shell also remains same, because the elements are arranged in ascending order of atomic number. Obviously, the atomic number keeps on increasing. For example, in case of lithium, in the case of sodium it is 11 and in the case of potassium it is 18. For example, in the case of lithium atomic number is 3, sodium 11 and potassium 19. So, obviously, in the case of lithium there will be 2 shells K and L, arrangement will be 2 and 1. In the case of sodium it will be 2, 8 and 1, shells are 3. In the case of potassium it will be 2, 8, 8, 1. So, the number of shells keeps on increasing. So, the next point will be, as we move down, in a group, the number of shells keep on increasing. Right. Now, there is something very interesting. There is something called atomic radius. Now, what is atomic radius? Center is the nucleus which has neutron plus proton, around it are the electrons. So, the more the number of shells, farther will be the outermost electron, the electron valence. So, the distance between the central core or the nucleus and the outermost shell is called atomic radius. This is the distance between nucleus and the outermost shell. So, obviously, if the distance will be more, the hold of proton on electron will also keep on reducing because they are away. They are beyond the influence, just like you people do sometimes when parents are not at home, you make mischief because that control is not there. So, similarly, in this case also, as we move from top to bottom, for example, that means the atomic radius of lithium will be less than that of sodium, and in case of sodium it will be less than that of potassium. Now, let us see what happens when we move from left to right, that is along with the period. As we move along the period from say left to right, what we find? Atomic number of sodium is 11, calcium 12, aluminum 13, silicon 14, phosphorus 15, oxygen 16, chlorine 17 and argon 18. So, there is an increase in the atomic number, but the number of shells remains same. Increase in atomic number from left to right in a period, but the number of shells remain same. Now, how is that possible? Let us take the case of sodium. In the case of sodium, it will be 2, 8, 1, 3 shells. In the case of calcium, it will be 2, 8, 2. Aluminum will be 2, 8, 3. Silicon 2, 8, 4. Phosphorus 2, 8, 5. Oxygen 2, 8, 6 and chlorine 2, 8, 7, argon 2, 8, 8. So, the number of electrons in the outermost shell have increased. Due to increase in atomic number, the number of electrons in the outermost shell have increased, but the number of shells remain same, that is 3. So, the third point is the number of in the outermost shell increases from left to right. The metallic nature of elements decreases from left to right and non-metallic nature increases. You must have noticed that I talked about the first three groups and then I also talked about the last three groups, but I didn't talk about the fourth group. Why so? Fourth group was of the group of carbon, silicon, etc. Why? Are they metals or are they non-metals? They are unique because they have both the properties of a metal as well as a non-metal. So, what are they called? They are called metalloids. Elements of fourth group have the properties of metals and non-metals. So, what are they called? Metalloids. They have only 4 electrons which can neither be gained nor lost. So, which kind of bond they develop? The covalent bond. So, they are more friendly, they make more number of compounds as compared to any other element. Now, coming to the position of hydrogen. You see, hydrogen has 1 electron only. So, as easily it can gain 1 electron, as easily it can lose. So, it has position both in the first group as well as the 17th group. So, hydrogen controversy was also solved. So, we can say hydrogen is placed on first and 17th group. The noble gases were grouped together and that was the 8th group.